Everyone. Thanks for your time. Thanks for joining us this webinar today. Well, when we were discussing internally if it was needed, this webinar focus on offshore data, we had some doubts. The point is that actually the technology that Vortex uses in order to calculate onshore wind data and offshore wind data, it's mainly the same. The WRF technology, the land use, the topography databases that we use, it's mainly the same. So at some point we had some doubts. The reality though is that the offshore projects and the onshore projects are every day more have more differences between them because the challenges that face each one of these projects tends to be much different. Today we will cover several topics. Okay, we will talk about a lot of things and very fast, probably because we don't have a lot of time, and we want to give you only some hints about what solutions, what Vortex it's currently doing in the offshore environment. Okay. First of all, we will talk about Vortex experience, and the first thing that we want to do is to raise a question about where are your projects in the world, all over the world. Now it will appear, which regions are you working on offshore projects? And you have different options. You have the North Sea in Europe, Ireland and UK, Brazil, Australia, China, Japan, India, or some others, because there are some other regions in the world that are being developed. Just mention that today's this webinar is mainly focused on Europe and Southeast Asia. And we will do another webinar in the future for US, okay, for America, let's say. Okay, if we can see the results, let's see what you vote, what you selected. People keeps on voting, so we will wait a few more seconds. Let's see which are the results. Well, apparently it's a little bit a surprise. There are others appears to be the more frequent answer, but obviously there are some other regions like North Sea and Ireland and UK, which are also very common as and also China and some other regions of the world. Okay, that was a little bit an excuse to explain that Vortex during the last year we have been involved. We have provided wind data for most of the areas where where offshore wind projects are being developed. Okay, we have provided data, and so quite often we receive feedback from the data that we provide. Based on our experience, one of the main characteristics of offshore projects is that having measurements, it's very difficult. We all know that only a few Met towers in offshore environments has been installed during the last years. Okay, and that the LiDARs, it's probably the most used method in order to measure wind all over the world. Okay, but it has its weaknesses that the offshore industry knows. Another important thing is that obviously we are in a different environment, which is water, and that raises some challenges that the developers should know, also manufacturers. And probably one of the most important challenges is the waves, the effect of waves, not only in the structures, but in wind production. Okay, we will try to talk about this today. If we talk a little bit about the technology model that we are currently using, okay, we use WRF. WRF is a numerical weather prediction model. Okay, that it was originally designed in US. Okay, and the main idea of WRF is using raw reanalysis data. The main ones are ERA5, MERA2, and CFSR, and other and topography data and land use data in order to generate smaller grids, in order to improve the resolution of the meteorological data up to 3 kilometer resolution or 1 kilometer resolution, or 100 meter resolution. based on Vortex approach, we suggest one product or another depending on clients' needs. That's more or less the way it works. Now we will talk a little bit about the standard solutions that you can find in Vortex interface. I'm not sure if you are all registered in Vortex interface. I encourage you to do it. It's free, so there are no charges, and there are some free data and some information there that you can have. Okay. When we talk about standard solutions, we always talk about standard solutions that tends to be used for offshore developers or offshore manufacturers. Okay. The first one that we will talk about is Vortex time series. Okay. Vortex time series, it's a long-term time series which are designed. Its main purpose is to correct the long term, okay, of your measurements. And we are able to provide you 10, 20, 30, 38 years of data. And the timestamp of that data sets are hourly. Okay, that's very important. And the final resolution of these data sets, it's 3-kilometer resolution. We don't have a bigger resolution for time series because in order, probably the main metrics in order to cross-check Vortex series, it's the correlation, and a 3-kilometer resolution is enough to achieve the highest correlation in general. Now we have another question that we want to raise, which is, which reanalysis source do you use in your resource assessment? Okay, we introduced 3 options, which we think are the most common ones, which is ERA5, MERA2, and CFSR. Another option, it would be depending on the site. Another option that we didn't introduce here is that to use all of them. We know that that several clients, they want to have as many information as they can for their sites. Okay, I'm not sure if it's ready, if everybody has voted. Let's see the results. It means that ERA5 is the most common data set used by the attendees. And then we have MERA2, and it seems that CFSR it's not as used, which it makes sense based on our experience. At Vortex, we always provide the information based on ERA5, CFSR, and MERA2. And this is not something that should be decided by Vortex, but it should be decided by you. We know that in general, ERA5 dataset performs better. As a general rule, at global level, we recommend by default to use ERA5. But we know that it's a site-dependent issue, and that in some regions or in some points inside a country where another dataset performs better, CFSR or MERA2 might have a better metrics. So at Vortex, what we propose actually in the interface, you have always 6 months of free data for your site so that you can cross-check with your measurements and decide which is the data set that performs better on your site. Okay, so I would encourage you to download that free data for 6 months and cross-check with measurements. Another thing that tends to appear quite often is how accurate you are. Okay, at some point that question always appears. It's a quite reasonable question, okay, to be fair. And regarding that, today we wanted to present an external validation that you can find in our knowledge center. Okay, it's an external validation for 13 offshore sites that it has been done for a company that probably some of you know, that which is called MedOcean Works. Okay, and we have done a validation of around 13 sites that it would be more or less half of them. Most of them are in Europe and in America, and there are a few, but only a few in Southeast Asia. Okay, I really encourage you to download the report. I think it's more than 100 pages report, so it's not easy. It's very complete. Okay, and mainly some of the the important things, to summarize some of the things that are said there, is that at heights, Vortex ERA 5 bias and root mean square error is closer to ERA 5 raw data in most of the sites. Okay, in low hub heights, the difference between ERA 5 raw data and Vortex ERA 5 data is even better for Vortex data. The difference is even bigger. Okay, and another thing that is mentioned there is for higher wind speeds, Vortex ERA 5 underpredicts by around 2 meters per second, while ERA 5 underpredicts by around 5 meters per second. So let's say that in general, the performance of ERA 5, of Vortex ERA 5 dataset, it's better. Okay. Now we change of subject, and we will talk again very briefly about Vortex LES. LES states for large eddy simulation, and it's the microscale model of WRF, of the model that we use by default. Okay. In this case, we provide 1 year time series, for a specific year that you will decide, or that we will decide in order to provide you with the long representative period. Okay, but there are different options. The second thing is that the timestamp of the dataset that we will provide you are 10 minutes data. And in this dataset, you will have standard deviation and 3-second gust. Okay, that's something that is very important, because probably it's one of the most important, it's one of the things that our clients value the most in this type of datasets. The resolution is 100 meters, the horizontal resolution. Okay, and clients in offshore environments, as you know, several LiDARs are installed, and not, and in general, having a Met tower, it's rare, let's say it. Okay, and so as far as there are some issues with the turbulence that provides a LiDAR, several clients wants to have a second opinion or another data set to compare the turbulence that has one side. So, and that's why they request Vortex LES data for these offshore sites. Regarding validation, in this case, we don't have an external validation. We only have an internal validation that we did around 2 years ago. Again, it's available in our knowledge center, and it's done for 18 offshore sites. Okay? And only in 5 of them we were able to validate turbulence. Okay, so let's say that the turbulence is not easy to validate because of there aren't many sites to do it. Okay, just inform you that around half of that sites are in Southeast Asia, and most of that Southeast Asia sites are in Chinese offshore waters. Okay, so if you are interested in Chinese data, in China's validation, then this document might be helpful. Okay, again, you can download it from our website. And now we move to another product, okay, which is Vortex FARM, which is a high resolution map, okay, which is simulated at 100-meter resolution, okay. And at this point, we wanted to raise another question, which is how big are the areas that you need to model? How big are your offshore projects? Okay, here we introduce just 4 options. It would be less than 1,000 square kilometers, between 1,000 and 1,500 square kilometers, up to 2,000 square kilometers, or more than 2,000 square kilometers. The main idea is that in general, the offshore projects tends to be much bigger than the onshore ones. So the areas that you need to cover are higher. I think that probably you are voting. I don't know. I'm not sure if we have the results already, but it tends to be a problem because the areas are very big when we talk about offshore. Let's see if we can have the results. Okay, that surprised me. I had in mind that probably you would request for much bigger areas, but it seems that about 40% of people, they have areas smaller than 1,000 square kilometers. Good to know. Good to know. In Vortex, we can cover easily areas up to 2,000 square kilometers. Okay, that's something that we can easily do. But again, in case that you have bigger areas or that you have a different area, just let us know, and let's think how we approach these areas that you have in mind that you want to analyze. Okay, the WRG file is one of the outputs of Vortex FARM, and it's probably the one that the clients prefer. Okay, with this WRG file, they are able to calculate production, they are able to calculate different layouts, and they have a lot of information to assess and pre-assess their sites. Okay, so they tend to like it a lot. And finally, we won't spend a lot of time on that today, but just let you know that we have a very strong and developed technology in order to calibrate farms with measurements. We call it remodeling. We can, in case that you wanted an explanation about how we do it, just let us know and we can arrange calls. Okay, but we have that technology that enables us to provide you with a WRG file without calibration and with a WRG file calibrated with your measurements, which clients tends to like a lot. Okay. Now I will raise another question, but before that, this is a very common question that came to us. The point is that several developers, they have an offshore area that they want to assess, but that area is quite close from an onshore area. And they are worried if that onshore area might affect their area of interest. And so they tend to ask if they need to model to include that A area in their area in order that we take it into account when we are providing the B area. Now we have a question here again, and that would be, what do you think? What if it's necessary or not to compute, to model A area in order to ensure that it captures the wind conditions of B area? Okay, here the answers are quite easy. It's yes, no, or I don't know. Which I don't know, it seems also like a pretty reasonable question. Answer. Let's see if people is voting. Let's see the results. Yes. Okay. Well, so based on your answers, it makes sense that we raise this subject, because actually the straight answer would be no. Okay, then at some cases the answer might be yes, but in general we would say no. Okay, at Vortex, when we are running WRF, when we are modeling a really huge area, when we are modeling an offshore area that is your project, we will deliver you only that area. But in order to deliver you that area, we have to model a much bigger areas. So we have to model a much bigger areas in order to know how is the methodology in that areas. And we start a downscaling process that for sure will cover the nearby areas. And so in theory, there might be exception, but as a general rule, your A area will be modeled. We won't deliver it to you because it's not your area of request. You don't need it, okay? But we have already modeled it, and we have already seen if something that happens in A area might affect the wind conditions in B area, okay? I think that I'm not sure if I'm fully explain myself. If not, just raise some questions, okay? Now we will talk a little bit about customized solutions. It happened in the past quite often that the clients, as far as they know that we have a lot of experience on wind modeling, they came to us with some proposal. They request us to do some things that aren't provided by default in the interface. but that it makes sense. It might help them in their project, okay? That solutions in general requires to exchange some calls or some emails, okay? So it's very difficult to introduce it in the interface. But we think it's good to let you know that we have these solutions in case that you faces similar challenges, okay? The first one is the wakes, how to analyze wakes, okay? WRF model, it has a wake model, which is called the feature parameterization, okay? This feature parameterization enables us to model an area and to generate grid maps at 1 kilometer resolution for your area, okay? And we are able to provide you time series and WRG outputs, okay? When we do this modeling, we do not model like long-term representative periods. We compute specific periods that need to be discussed with you, 1 year, 2 years, and we compute that periods in order to have the time series, in order to ensure that the time series are reasonable. When we do this WRF parameterization, feature parameterization, okay, we will need some information from you. That's one of the reasons that it's very difficult to introduce it in the interface. Some of the information that we will need is the hub height of the turbines, the layout, the coordinates of the turbines, the diameter of the rotor, and some other metrics, some other information from your site. Okay. What we will do, what we have done, is that we will run a WRF free wind parameterization. Okay, which it would be like the picture that you have in the left. You will have like a free wind information, and we will also launch a feature parameterization with your layout of turbines, and so you will receive 2 data sets, one with free wind and one with wakes. Okay, in some cases we have run different feature parameterization with, for example, different wind farms. Let's assume that in 10 years, another wind farm is installed in that area. How it will affect my project if another wind farm is installed, that kind of things. Based on the validation that we have done, we do not recommend to use this feature parameterization in order to capture in a correct way internal wakes, okay? We do not recommend that. But based on also on feedback received from clients, we think that it's quite good capturing external wakes. Okay, so it's something that maybe it's good you to have in mind. Another customized solution that we have and that we wanted to talk about today is the low resolution grids. Okay, in this case, we are able to provide long-term gridded time series for a 10-year period, for a 20-year period, for a 30-year period, okay, for our regional areas. In this case, we are not analyzing one offshore project, but we are analyzing an area, and we will provide you information at 3-kilometer resolution or 1-kilometer resolution. We will be able to provide you with net CDF files so that you have all the grid, all the data set on your site, okay? And in general, these data sets are requested for 2 purposes. The first one is to assess or pre-assess new areas. Okay, when a new area is being developed and a government gives the green light in order to start developing one offshore area, several companies they want to have all the data set on their site in order to start working with different layouts, different projects, and to analyze on their site. And another purpose of these data sets is to calculate waves. Okay, in order to calculate waves, you need a really long period, and this data set, this low resolution grids might be helpful. That's pretty much what I wanted to explain today. Now we will answer questions, and a little bit to summarize what we wanted to explain today is that we have experience in most of the regions where offshore projects are being developed worldwide, and we tend to receive feedback from our clients. So just let us know which are your doubts, your challenges. Then the standard products that tends to be requested for offshore environments are series at 3 kilometer resolution, LES at 100 meter resolutions, and farms at 100 meter resolutions. These are, let's say, the standard solutions. And that we have also customized solutions. Regarding that, I would suggest you to talk to us. Okay, it's very difficult just to give general rules, but in case that you find challenges or issues that you think that might be solved, or that the wind data provider might help you on that, just let us know and let's try to discuss that. Okay. At Vortex, we spend a lot of effort on validate Vortex data. Okay, we do it internally and with 3 parties. In onshore projects, we have done it in thousands of sites, okay, hundreds of or thousands of sites, because there are lots of towers available. Obviously, in the offshore environment, there aren't that many questions, that many met towers or lidars available. So our validations are smaller, let's say. But even though, just ask us about feedback. Okay. And finally, in our website, in the Knowledge Center, we have a lot of information. We have lots of documents, and some of them are regarding offshore. Okay, and you will find the validations that we talk about today, and you will find some other documents, some other presentations that we have done in exhibition, in conferences, etc., that might be helpful for your specific problem. Just as an example, in our Knowledge Center, there are some presentations about Vortex wind data regarding stability of the atmosphere. Okay, that's something that might be helpful, but it's very specific. But if you have that problem, we might help you on that. That's more or less what I wanted to say. Thank you for your attention, and if you have questions, maybe it's time to raise it.
Okay, thank you very much, Jordi, for the presentation, and Uriol, thank you for answering the questions during the presentation. You can find them in the Q&A section. Some of them Uriol has already answered them, but we are going to ask Jordi and Uriol some of the questions that you have raised here in the Q&A section. Let's start it with the first one. Luca has asked us, for what concerns the wind data, how Vortex model the turbulence intensity for the offshore sites? Uriol will answer this question.
LES is certainly solving the equations for large GD simulations, while the other products does not explicitly solve them. We have a parameterization which generates the information for turbulence, but it's not very reliable in terms of time series. So it's you can have the information for collapsed statistics, but it's we recommend using LES for detailed information on that.
Perfect, thank you, Uriol. Neil Richard is also asking, can you use the Vortex series in initially assessing the wind resource in the area without any on-site measurement?
I would not recommend that. Typically what we've seen from our clients for initial assessment, they typically use other products such as maps, and they can compare with other sources and check for best places in the.
If I may add something, it's something that we do not recommend. Okay, that's we would like to strengthen that. Okay, but there is some error in my audio. It's something that we do not recommend. Okay, but several clients do that. Okay. And we have to take into account several clients. They want, in order to assess their projects, they use Vortex 3 kilometers resolution time series. It's something that the product is not designed in order to do that, but we have to be aware that several clients do that.
Thank you, Jordi and Oriol. Mans Hackanson is also asking, what is the difference between Vortex SERA 5 and the road one? Do you perform any modeling in the process?
No, yeah, I didn't go into detail regarding that. In the document that you can download, it's very well explained, but it requires explaining it right now. It would require a lot of explanation. But it's if you go to the document, you will see exactly how the comparison between Vortex raw data, ERA 5 raw data and Vortex modeled data, it's done. Okay, which are the metrics and how it's properly done. So, but you will have to go that because it's not an easy thing.
Thank you. And Antoine Borrachino, Jordi, the 2,000 square kilometers is still an okay size for the largest software project, but most likely not enough if it is to include neighboring sites. I think Antoine is referring if the other areas that we are computing counts in the final area. I think is what he means.
And regarding the area, to be fair, the difference in the area requested tends to vary a lot. Okay, to be fair, it surprised me that when we answer you how big are your areas, it was very common to say below 1,000 square kilometers, because based on our feedback, people want much bigger areas. Okay. So regarding the exact area that you need, I would suggest you to send us some emails and to ask us specifically which is your area of interest.
Okay, I think I think Antoine was referring to the point that the 2,000 square kilometers includes the A area that we compute in this example that you put A and B. Do you know?
Yeah.
No,
maybe.
Yeah, I think he's pointing that when you are not considering neighboring wind farms, did you know? But most projects are now nearby other wind farms, and they want to consider the wakes, and in that cases the area is not enough. As Jordi explained, with our 1 kilometer resolution, we can cover much bigger areas of 20,000 kilometers square. And although it's a low resolution 1 kilometer simulations, it can cover very big areas, and we also can include the pitch parameterization with wakes. That Jordi explained, it's designed for neighboring wind farm wakes, not internal wakes. And I think there's a question about that.
Okay, thank you. Anselm Grotzner, for offshore, 500-meter resolution will be sufficient for a farm. That resolution was available in the past, but disappeared. Why?
It disappeared because we were able to provide the same area at 100-meter resolution. Okay, that's the straightforward answer. Let me tell you that right now, as we know that for offshore projects, sometimes the 500-meter resolution is enough. Okay, we can compute it. Okay, today we didn't talk about that. We didn't explain it as a customized solution. But if actually you think that for your area 500-meter resolution, it's fine. We have the technology in order to do it, and we keep on doing it. But let's say that we do it in a customized option, because we didn't mention that. But in general, we try to keep our interface very clear, very clean, in order to ensure that it's very easy to be used. Okay. but you can answer if you send us an email. It's something that it can be done.
Okay, Fernando del Jesus is asking, talking about farm, the A and B areas, how would you deal with onshore measurements for calibration of farm that are outside of the objective area?
Okay, in that case, in case that you have a LiDAR or measurement outside your area, and we have done it several times, then we need to extend the area. In that case, we will need to extend the area in order to cover your measurements. Okay, that happens pretty often, that there is a LiDAR that it's nearby, and so that we have to increase much more the area that we are computing in order to cover that LiDAR, and so that you either you validate, you cross-check on your side, or we also calibrate the whole model with the information.
I want to know that we've received some questions about that, if doing this or not, because in the setup there was this question that they had a measurement in onshore and wanted to extend this information to the offshore area. And we have to say it varies a lot depending on the site, that if this is a reasonable approach or not. So you must take care when calibrating offshore areas using onshore measurements.
I think Fernando was referring to if he has onshore measurements for calibration.
Okay, that's what Oriol was saying. Okay, we have done it. To be fair, I would do it as far as from the cost point of view, it doesn't cost our clients more. And so they would receive two WRG files, two files, one calibrated and one without calibration. And so at least they would have an approach. So I would prefer to have the information, and then I would decide if it's useful or not. Even though, as Oriol mentioned, it's something that we have to be a little bit careful about that, and we have to I mean, there might be things that have to be considered. I mean, it's not the regular calibration. It's not the ideal situation, let's say.
Do we have experience in South Korea offshore? Do we have any validation in South Korea for offshore sites?
Yes, we have. As I mentioned, if you have questions about specific areas and you don't find it in the Knowledge Center, just let us know, and we can try to cover a little bit, which is the feedback or the validations, specific validations that we have done for specific clients when they ask us, okay, regarding South Korea. What I remember, because we did it 2 or 3 years ago, it was also regarding offshore sites. I don't have it's not published in the website, okay, this validation. But what we did is that we cross-checked how accurate they were, our Vortex series, against some Met towers, which were public data in that site. And our client, they were also worried about typhoons, okay? And they wanted to know how if we were able to capture the typhoons, how accurate we were, and to compare how were the different sources were good in order to compare MERRA2, ERA5, and CFSR, which was the source that captures better a specific event like a typhoon. Okay, so in general, we have experience, but not everything is in the Knowledge Center.
Mans Hackanson wanted to, he says everything was clear, Oriol, but he has another question raising that. Will the coastline, if outside of the requested area, be run at the parent grid?
Yeah, man. For a general rule, our simulations are done scaling using grids, nested grids in a relationship of 3. So the parent grid you are seeing, the first parent grid will be 3 times bigger than your domain you are receiving the data from Vortex. So that way you can more or less know if that parent grid is covering the area you are interested. For example, in case of of Era 5, which is 25 kilometers, you got several grids involved. 25 more or less to 9 to 3 1. That's the rule of thumb to know how big are all the different grids based on your area.
Even if I may add something regarding parent area, sometimes even the A area, if it's quite close from your area of interest, it's also covered at 100-meter resolution. Okay, it's just that we take it out because there is always a buffer area that it's not included in the area that we are providing. Okay.
Okay, some other attendee is asking about external validation on wake models, and Sam Shu is also asking why we do not recommend internal wake calculation. So these are two questions regarding the wake.
Well, regarding wakes, well, I will go for the second one first. We don't recommend for internal wake at this point, first of all, because we don't have a proper validation, okay? And we have a feeling that there are some other tools that might be more accurate, okay? So there are like two things, okay? It's that we haven't received feedback about that. And there are some very advanced tools that I think that captures pretty well, or at least better than us, the wake effect. That's why we tend not to recommend it. Okay, we recommend to use it for external wakes. Okay, and the first question, sorry.
The first question was if we have external validation on wakes.
We do not. We do not. In the external validation that you have for time series, it's done by a company which their main strength it's no, it's wave. Sorry, it's not wave. We have sorry an external validation regarding wakes, but we cannot share it. Okay, so that's one of the things that we have to take into account, that there are some confidential issues that has to be considered.
Okay, thank you. I'm afraid there are still 25 questions not answered, but we have reached the time. So we already have the 45 minutes of this webinar, but we are going to answer all of them and send it to you, okay? So you will have the answer of all these questions, but we have to leave now because we have reached the time. Thank you very much, all of you, for all your questions, for the interest in this topic. We are very happy that you find it so interesting. And as I say, we will send you the webinar recording, the webinar presentation, all these documents that Jordi was talking about, the validations, and also all these questions that you ask with the respective answers. And just to finish the webinar, I want to inform you that we are going to be in Copenhagen next week in the Wind Europe Electric City 2021. Our stand is the C2, C22. So please come by if you are in Copenhagen, and we can keep talking about offshore and other products like Vortex blocks. We will have presenting Vortex Extremes, Vortex blocks, and also we will have a stand party. You are all invited to come by if you are there. We will have beer and some ham and some talk and a nice chess game if you feel like. So you are all invited there, and we thank you very much for joining us today and for your interest in this webinar. Thank you very much.